Have you ever wondered what music tuning is? Perhaps you've seen people tuning their guitar or piano and wondered what they were doing. Well, the musicians are actually adjusting or tuning their instruments so the sounds they produce follow a tuning system. We use tuning systems because humans love organization and patterns. So when sounds, or pretty much anything else in life, follow patterns and have consistency, we find that very pleasant. So what tuning systems are the musicians actually using? Well, in reality, there are many tuning systems that can be used. Modern-day Western music uses a system called 12-tone equal temperament, and before that, a popular tuning system called Just Intonation was used. This video will have a few parts, two of which will be dedicated to explaining these two tuning systems. But first, we need to talk about something that was highly influential in the creation of tuning systems, called the harmonic series. The harmonic series is a sequence of frequencies. This diagram represents the harmonic series. The biggest standing wave on the left is called the fundamental. The second wave is called the second harmonic, or the first overtone, and it resonates at twice the frequency of the fundamental. Now this diagram just shows the first few waves, but this pattern continues for the third wave and the fourth wave, theoretically going to infinity. Notice how the frequencies are integers of the fundamental, so whole numbers like 2, 3, 5, not numbers with decimals. When you play a note on an instrument, the instrument interacts with the air, producing sound waves. These sound waves follow the harmonic series. The pitch of a note is typically the fundamental. For example, in music, the fundamental of the note A is usually set at 440 Hz. So if we play a sine wave at 440 Hz, it produces the pitch of the note A. We can verify this by comparing the sound of the note A on a piano. You'll notice that it produces the same pitch. Remember I said that the waves an instrument produces follow the harmonic series. This means that the piano not only produces a wave at 440 Hz, but all the waves of the harmonic series. So when you hear this note on the piano, you are hearing the fundamental, but the piano is also producing all these harmonics and overtones as well. They're just very quiet, so the fundamental frequency is still the main thing that you hear. Now what does all this have to do with making music and tuning? Well, to answer that, let's look at part 2, the organization of notes based on the harmonic series. So I'm sitting at a piano because I want to explain something that might help you understand the concept I'm going to reference later called octave equivalence. So if we look at the keys of a piano, you'll notice a pattern. This section is the same as this section, which is the same as this section, which is the same pattern for the whole keyboard. So what does this mean? It means that the keys in the same place of the pattern represent the same note. So this note is called A, and this note here is also A, and this note here, still A. Just note that this A is higher than this A, and this A is higher than this A. But what does higher mean exactly? Well, a higher note has a higher frequency. This note A has a frequency of 440 Hz. All the notes higher than this A will have a frequency faster than 440 Hz. That's cool, but why are all these notes called A? Well, it turns out if you double a frequency, it's considered the same note. Take, for example, the frequency 440 and 880. The frequency 880 has, in a sense, the frequency 440 embedded inside it. So when 440 is played with 880, the sound quality has a sameness. Another way to think about this is that the frequency 880 is literally the second harmonic or the first overtone of the frequency 440. This extreme sameness of the sounds led to them being classified as the same note, and this is called octave equivalence. So now we understand that sounds at higher and lower frequencies can still be classified as the same note. So looking at the harmonic series again, let's play the first 30-ish harmonics, which is pretty much up to what the human ear can detect. After playing the first 30 harmonics, the amount of different notes we get is 12, and these 12 notes turned out to be almost equally spaced between an octave, and so these 12 notes would become the standard for music, eventually giving rise to tuning systems. Just intonation is directly derived from the harmonic series. A quality of this system is that all note frequencies can form ratios with any other note. The octave forms a 2-to-1 ratio, or these two notes form a 5-to-6 ratio, and these two notes form a 6-to-7 ratio. Unfortunately, for these ratios to be possible, it means that these notes are not equally spaced apart. Notice how in these two cases both are separated by 3 notes, yet the ratios are different. So although notes in just intonation sound great when played at the same time, the notes also have an uneven quality when notes are played one after another, like in melodies. The solution to this was 12-tone equal temperament, or 12-tet for short. The formula 12th root 2 to the n was used to set the note frequencies, with n being the number of the note in the octave. 12-tet favors equal note spacing and has no ratios except for the octave. However, the fractions created by the notes are still quite similar to just intonation notes, so 12-tet still sounds pleasant. In summary, 12-note Western music and tuning was not created randomly, but was in fact highly influenced by the natural phenomenon known as the harmonic series. This concludes my video. Thanks for watching.